So this is the first question that we have for today. It is from the past paper of 2022, May-June paper 21. And most of the parts, the question are from the topic of moment of force. The very first one that we have is state what is meant by the center of gravity of an object. So center of gravity of an object is a point where the entire weight of the object seems to be acting. Alright, so basically it is a point of the object. If you want to balance an object, all you gotta do is to apply the force against the weight at the center of gravity, and that would be the easiest way to balance the object. So let's move on to the next question. A non-uniform rod XY is pivoted at point P. So this is your pivot. Non-uniform rod means the center of gravity of the rod is not exactly in the middle. If it were a uniform rod, and let's say the total length of the rod were 4 meters, but for a uniform rod, the center of gravity would have been exactly at 2 meters mark. But since this rod is non-uniform, so there might be a little bit of more mass concentrated on one side than the other one. So anyway, then we have some of the specifications. Okay, they have just described what they have shown here in the figure, so I'm going to skip the description for a moment. A force F is applied vertically downward, and we can see that as well. And more importantly, the horizontal rod is in equilibrium. So means now we have the license to apply the principle of moment about any point of the horizontal rod by taking moments at about P. Now they have specified the point as well about which we need to apply the principle of moment. That's even easier. By taking the moments at about point P, calculate the value of force F. So P is your pivot. Okay, so this is your pivot. I'm going to shade it. This is your pivot. Now let's check out the forces that would rotate the rod clockwise. So here you have the first one. This force would rotate it clockwise. Then you have the force of 3 Newton exactly at the end that would rotate it clockwise. I'm going to write C over here, C over here, and the force F would rotate it anti-clockwise. Now what is the principle of moment? Sum of clockwise moments equals the sum of counterclockwise moments, then the object is in equilibrium. So for the anti-clockwise moment, we have the force F being applied at a distance of, with a perpendicular distance of 1.10 from the pivot. So the moment would be, anti-clockwise moment would be F times 1.10. So we can write over here F times 1.10. This is what we have from the anti-clockwise side, and that's it from the anti-clockwise side because there is no other force that would rotate it anti-clockwise. Now let us add the moments clockwise. So here we have the first one, 44 Newton, and what is the perpendicular distance of that force from the pivot? It is this distance. And how much is that? It is 1.70 minus 1.10. So it's not given directly, you can sort it out, and this distance would be 0.60 because we need to find the distance, perpendicular distance between the force, line of force, and axis of rotation or the line of pivot. So this distance is 0.60 meters. So 44 times 0.60. But then you have another force that will rotate the rod clockwise, and that is this force of 3 Newton. And what is the distance of that force from the pivot? The distance between the line of action of force and the pivot and the line of pivot is represented by the green line for the force of 3 Newton. Now then the question is, how much distance is this one? So you have a total distance of 4, and you can subtract this much distance from 4. If you subtract this much distance, you'll be getting the distance represented by the green line. So how much is that? 4.00 minus 1.1. What do you get? You get 2.9. So the perpendicular distance between the force of 3 Newton and the pivot is 2.9. So you multiply it by, the force was 3.0, multiply by 2.9. Then you rearrange it, find the value of F, sort this one out, and divide whatever the answer of this thing is, divide that answer by 1.10, because 1.10 being multiplied on the other side, once you shift it on the right side, it would be divided. So the final answer that you'll be getting from here would be, in 2SF, it would be 32 newtons. Alright, simplification, you just need to use the calculator for it. Let's move on to the next part. Calculate the force exerted on the rod by the pivot. Force exerted on the rod by the pivot. So how much force the pivot is exerting on the rod? That equals to the force that the rod is exerting on the pivot. Action and reaction are equal in magnitude, but opposite in direction. So the total force that is being exerted on the pivot is this much plus this much plus this much. And what was the value of F? 32. So whatever the sum of these forces is, that is the force that the rod is applying on the pivot, and then in return the pivot would apply the equal amount of force on the rod. Okay, so you add it, hit it on the calculator, you'll be getting 79. 2SF, you'll be getting 79. So this is a force that the rod is exerting on the pivot, and then in return the pivot would exert the same force on the rod, in consistence or in accordance with the Newton's third law of motion. Okay, then we have the next one. The sphere in B is now immersed in a liquid in a container as shown in figure 2.2. So you have the same situation, but now there's a liquid and the sphere is now immersed in the liquid. So that's the only variation. Use Archimedes' principle to determine the radius of the sphere. This is basically linked with the chapter of pressure and density. Over there we study a formula. That formula reads that the upthrust is represented by U. That equals to rho G V. Rho represents the density of the liquid. G is the gravitation field strength or acceleration of free fall, and V represents the volume of the object, and U represents upthrust. Okay, we'll study this one explicitly in the chapter of pressure and density. So what do you do from there? You'll use the value of upthrust as 2.5. The density of the liquid would be used as 1100, is given over here. The upthrust is also given. The value of G, we know indirectly that G equals to 9.81 meter per second square or Newton per kilogram, and the value of V naught which is the volume of the sphere, is not given, but we know mathematically that the volume of the sphere is 4 over 3 pi r cube. So what we write is, we write u as it is, we'll insert the value of u, we'll insert the value of density of liquid, we'll insert the value of gravitational field strength, and instead of volume we can write 4 over 3 pi r cube. So from this equation you'll realize that all the other variables are given. The value of u is given 2.5, this thing is given 1100, this thing is given 9.81, 4 over 3 is constant, pi is constant, and you can find the value of r cube. Then you can take cube root on both sides and you'll be getting the value of the radius. So this is how we solve this one. But since we are not done with this topic, so I'm going to skip the calculations for now. If you want to do it by yourself, you can. You'll be getting the answer through this expression. Let's take a look at the next part. Calculate the magnitude and direction of the resultant moment of force on the rod about point P. In this situation, when you have placed the sphere in the liquid. So once you place the sphere in the liquid, there was an upward force, upthrust, which is 2.5 Newton, 2.5 Newton over here. So the upthrust acting due to water on the sphere is 2.5 Newton. It would be upward. What was the weight of the sphere? The weight of the sphere was already given, and that was, for the weight of the sphere, it was 3.0 Newton. So you see, at the last point, at the end of the rod, there are two forces acting in opposite direction. Now, what is the resultant of these two forces? If you have a force of 2.5 Newton upward and a force of 3 Newton downward, what is the resultant force? The answer is, whenever we have the forces in opposite direction, we subtract the forces. So 3.0 minus 2.5, we get a force of, resultant force of 0.5 Newton downward, because the greater force was directed downward. So the overall force at this point, I'm going to remove these two forces and I'm going to label, or I'm going to write only the resultant force at this point, which would be 0.5 Newton downwards. So I'm going to remove this thing. There would be a resultant force downward. How much? 0.5 Newton. And how do we get it? Now I can write over here 3.0 minus 2.5. 3.0 was downward, 2.5 was upward. So that's why you get a resultant force of 0.5 Newton downward. Let us apply the principle of moment now. So everything else would remain the same, just the last force would change from 0.3 to 0.5. So sorry, from 3.0 to 0.5. And everything else would remain the same. So we do have the value of F as well, which is 32. Okay, this force we calculated already. This force is 32. And what is the perpendicular distance of this force from the pivot? It was given in the previous diagram, 1.10. Which one? This one. So for anti-clockwise, we have F, which is 32 times 1.10. There's no other force that would make it rotate anti-clockwise. So this thing equals, what are the forces clockwise? One of them is 44 Newton, this one, and the perpendicular distance of that force from the pivot is just the same, 0.6. You can see over here on the previous diagram 44 times 0.60. So what we write here is 44 times 0.60 plus, because there's another force that will rotate it clockwise, which is a resultant force of 0.5 Newton. So 0.5 times 0.5 times the perpendicular distance of that force from the pivot, which is once again 2.9. How do we know? We labeled over here. You see, this distance of the 3.0 force from the pivot was 2.9. Okay, so this thing equals 2.9 meters, 2.90 meters. So we write it over here. Then we hit it on the calculator. We hit the left side on the calculator and right side. So on the left side we get 35.2, and on the right side we get 1.45 from here, 1.45 plus 26.4 over here. Then you add these two, subtract it from 35.2, and the answer that you'll be getting is 7.35. So what is the magnitude of the resultant force? 7.35, or if you want to write in 2SF, it would be 7.4. And what is the direction of the resultant moment? So you see, there was more moment anti-clockwise than there was clockwise. So the direction of the resultant moment would be anti-clockwise, because for the moment anti-clockwise the answer was greater than for the moment clockwise.